Now we're going to work on the bread and butter model of macroeconomics, the aggregate supply, aggregate demand model. First, we want to understand where the aggregate demand curve comes from. And the aggregate demand curve is a curve that shows the relationship between the level of prices and the quantity of real GDP demanded. We talked earlier about supply and demand for individual markets and individual goods. This is the aggregate demand. It's the demand for all goods and services produced in an economy. And the price is the general level of prices. So when we look at our aggregate demand curve, we're looking at GDP demanded and the general level of prices. It's downward sloping, like other demand curves. And on the horizontal axis, we have real GDP. On the vertical axis, we have the price level. So aggregate demand tells us at any given price level what the demand is for all goods and services. So let's remember what we have in our aggregate demand curve. We know that GDP is C plus I plus G plus net exports. So when we look at our aggregate demand curve and we look at why it's sloped downwards and what makes it shift, we're going to look at anything which affects any of these variables. Now, first of all, why is it sloped down? Well, as the price level changes, the value of our nominal wealth changes as well. So suppose prices go up, any wealth that I have, which is valued nominally, like cash, so any cash that I have, no matter what the price level is, a $100 bill is worth $100. So as prices go up, that $100 bill becomes worth less in real terms. So I can buy less goods and services. The consumption is going to fall. So as the price level goes up, the wealth effect decreases the quantity of aggregate demand. So we have a downward sloping aggregate demand curve. Just like any other demand curve, it's downward sloping. So we can think of it as the law of demand for aggregate goods and services. Now, what makes the aggregate demand curve shift? Well, remember, anything which affects consumption or investment or government expenditures or net exports is going to shift aggregate demand. Now, we already saw that when the price level changes, we move along the aggregate demand curve. Anything which increases investment, consumption, government expenditures, or net exports, other than changes in prices, is going to shift the aggregate demand curve to the right, meaning that a higher level of aggregate demand at any given price level. Anything which decreases consumption, investment, government expenditures, or net exports, other than a change in the price level, is going to shift the aggregate demand curve to the left. So, for example, if we decrease taxes, people will have more disposable income and thus spend more on consumption. Aggregate demand curve shifts to the right. An increase in taxes will have the opposite effect and shift it back to the left. If you increase government spending, well, that increases G. Aggregate demand curve shifts to the right. A decrease in government spending is going to shift it to the left. And as we'll see later on, an increase in the money supply is going to increase aggregate demand. We'll see that later when we talk about monetary policy and money markets. Conversely, a decrease in the money supply shifts the aggregate demand curve to the left. Now, what we're going to see is something very interesting. If we shift the aggregate demand curve, say by an increase in government expenditures, that initial increase in aggregate demand will be equal to that change in government expenditures. So this distance right here is going to be equal to the change represented by delta of government expenditures. But what we'll see in the end is that the overall shift of aggregate demand is going to be bigger than that. And we call that the multiplier effect. How much does aggregate demand curve shift? Well, it actually shifts more than the initial increase. Let's see why. Suppose we increase aggregate demand by $10 million. Well, as we saw when we looked at the circular flow, an increase in purchases of goods and services becomes an increase in income. Because to produce those goods and services, we have to pay workers, and that workers get paid income, and so income goes up by $10 million. Now think about what happens to that income. As we saw when we looked at the circular flow, that income is either spent on consumption goods or it's saved. It all depends on how much is being saved. But suppose we spend 60% of our income, well then that increase in income of $10 million is going to become an increase in consumption of $6 million. So we had an initial increase in aggregate demand of $10 million. Maybe it's an increase in government expenditures. Maybe it's an increase in investment. Something shifts the aggregate demand curve by $10 million. That becomes an increase in income, which increases consumption demand by $6 million. Well, we know that consumption is also part of aggregate demand. So now, in a subsequent round, as we go back around the circular flow, aggregate demand goes up by another $6 million, which becomes an increase in income of $6 million, which we now spend 60%, or $3.6 million, on consumption. Now, just as the first round created a second round, the second round creates a third round. That $3.6 million increase in consumption increases aggregate demand, which increases income, which increases consumption, and so on and so forth. And we can see that eventually that $10 million increase in aggregate demand is going to increase total aggregate demand by $25 million. Now, how do we see that? Well, we're going to put together a formula for what's called the multiplier. And the size of the multiplier tells us how much aggregate demand is going to increase for an initial increase in aggregate demand. And as we can see from this example, the more of an increase in income which is spent on consumption, the higher the multiplier is going to be. Because suppose we spent, instead of 60% on consumption, we spent 80%. Well, then this would be $8 million. This would be $8 million. This would be $8 million. And then this would be 80% of $8 million. So all of these would be bigger. And all of these would be bigger. And this would be bigger. So we need to understand this relationship between income and consumption. In order to do that, we look at something called the consumption function. The consumption function tells us if income changes by some amount, how much does consumption change? And it's related to what's called the marginal propensity to consume. This letter here, B, represents the marginal propensity to consume, which equals the change in consumption for a change in income. The larger the marginal propensity to consume, the larger the proportion of changes in income, which become consumption, the larger the multiplier, which is the ratio of a total shift in aggregate demand to the initial shift in aggregate demand. Now, it turns out we have a very simple formula for it. The multiplier, in the simple model, is equal to 1 divided by 1 minus the marginal propensity to consume. So, when we try to look at the overall effect of a change in aggregate demand, we take the initial change in aggregate demand, multiply it times the multiplier, and that gives us the total shift in aggregate demand. You're going to do lots of examples of how to use the multiplier and how to compute the multiplier as we go through this chapter.